So it is new day and new problem. Today we will solve binary search in LeetCode, and the problem is 672 prime number of set bits in binary representation. So we will solve this question by our some steps. First of all, we will discuss the problem statement, that is it is, and its input and output. Then we will try to understand its identification, that how we can solve this question. Next, we will discuss about its explanation, that how we will convert our identification into code. Then we will explain this identification. Next, we will code, and after it, we can try run of this code. So let's start our problem statement and input output. The problem statement is saying that given two integers left and right, it is left and right. Return the return the count of numbers in inclusive range left and right. Count inclusive range should be include left and right also. Having a prime number of set bits, and set bits will be like 1. We will we will run around the ones bit in their binary representation. Recall the number of set bits an integer has is the number of ones present when written in binary. So our set bits will be ones. We know we have that only two bits, 0 and 1. So our in this question we have the set bit is 1, and the question is saying that we have to calculate the numbers, how many numbers between the range 6 and 10, eh, that that has bits that is in prime. Like, let's see this example. Our first input is left is 6, right and 10. So we will work in this range of including 6 and 10. Our work is to first of all we calculate the binary of specific number. So we have first of all put the value, take the value 6, and find its binary representation. Its binary representation is 1, 1 and 0. So question is wants that calculate the its set bits. So here set bits is 1 and 1. It's two set bits. Okay. And 2 is prime. Okay. So we have we have till 1 numbers that is prime set bits. Okay, understood. Next one will take 7, and 7 is in between 6 and 10. Okay. And 7 has the prime binary representation is 1, 1 and 1. Okay. And 1 is, as you know, 1 is a set bits, because the question is also saying that number of set bits of integer has in the number of ones present. So 1 is the set bits. So in this we have three set bits, and 3, as you know, the 3 is prime. Okay. And let's take another add, and add also the in between 6 and 10, and adds a representation in binary form is 1000. Okay. And here the 1 set bits, because 1 only 1 times. And as we know, 1 is not a prime and not a even and not a odd. Okay. So next one I have the 9. 9 also in between 6 and 10. So 9's representation is 1001. Okay. Here we have the two set bits, 1 and 1, and 2 is, as you know, the prime number. Okay. And the next one we have the 10, and the 10's representation in binary form is 1010. We in this example we have the two set bits. We have two set bits, and 2 is also prime. So if we talk the how many numbers that have the set bits in prime, set bits are prime in between the range 6 and 10 is 4, because this one have the two set bits and 2 is prime. So 1, 2, and we will not calculate this, because the 1 is not a prime and not a odd. So 1, 2 and 3 and 4. So the four numbers have a prime number of set bits. That means ki the four numbers are there are four numbers in between the 6 and 10 that has the set bits and their set bits in the prime number. I hope you have understand the problem statement that what is the question want to saying and what is the question is want to calculate something. So next we have done the problem statement and input and output. So next we have to find out the identification that how we can solve this question. Let's take it that first of all, as we know that the question is saying the binary representation. So first we have to calculate every number's binary. Okay. So how we can do in the binaries identification steps. So first of all, we need to find out the binary representation of that number. Binary representation. Next one will be next one. We have to calculate the set bits. That how many set bits in present in that specific binary representation. So that we have to calculate set bits. Next one, how we can that after the set bits after the set bits, the question is saying that this set bits is prime or not. So that so after it we have to check the prime number that the set bits in prime number or not. So that after it we will check prime or not. Okay. So I thought you understood that will be our questions flow and after it, will solve this step by step as well. Understand our binary representation. After it, calculate the set bits and check that set bits is prime or not. We will use our while loop, and while loop will be run. While loop will be run from left to right. Okay, we will run our while loop from left to right. In this example, we will run our while loop 6, 7, 8, 9, and 10. So let's start to try to solve our questions because we have understood our problem statement, input, output, identification, and also we have discussed our explanation. So let's see that how we can solve our questions. Okay. So we have the count prime bits functions. So at the end we have to calculate the number that how many numbers are in between that have set bits are in prime. So we have only integer output. So let numbers numbers initially number will be 0 because there will be any condition that have the zero number that have the prime number set bits. Okay, we will have the separate bit that will give us the set count set bits that mean number of set bits in that specific number. So let count set bits is equals set count set bits and in that specific function we will give the left functions left number and before starting the calculate our count set bits we will use our while loop to calculate our specific number. So while our while loop will be run from the left to right, left less than equals to right. Okay. and we will calculate our count with set bits in the while loop. Okay. After count set bits. The count set bits will be the number of set bits that are present in the specific number. And another function will be give us a true or false value that the number is prime or not. So our new function is function check prime. This function will help us to check the prime that the number that the set bits are a prime or not. So we will pass the count set bits in this function. Okay, we will define our function after this. So first of all we decide first of all we write our check prime number function. So let's for easy understanding we will use as n and here also n for the better understanding. So if n less than equals 1, if n less than if n less than 1, that means return return false because less than 1 function always false value return. If n less than 3, less than or equal to 3 because 2 and 3 always a prime number. So return true. Okay. If any number is divisible by 2 or divisible by 3, then the number will not prime. So if n is percentage by 2 equal 0 or n percentage by 3 equal 0, that means our number will not prime. So we in this condition we will return as a false value. We have we have checked that 1, 2, 3. After which we will check that our number is prime or not for bigger values. Let's start our loop for let I is equals 5 and I multiplied by I less than equals n and I plus equals 6. If n percentage by I equal 0 or n percentage by I plus 2 equal 0, then we will return it or return false value. Okay, if all any of condition is not satisfied, then our number will always prime. So this condition in that condition we will return as a true value. Okay, so if our function check prime gives us true value, then we will increase our number by 1. So if check prime of n, that means if it gives value a true value, then we will increase our numbers by 1. That means the specific number have the set bits and the set bits are in the prime number. After it we will increase our left variable by 1. Now we will return our count count set bits. That means we will count our set bits in a specific number. Let's try to write our function that is count set bits. So count set bits is equal count set bit function left will give the left bit is equals initially 0 while our left greater than 0, then we will calculate our value. If left percentage by 2 equal 1, that means our set bit is form 1. That means we will bits increase by 1. Sorry, here we will try to do this. Okay, and after it we will divide by 2 on the left, and left will be the math dot uh, floor and the left divide by 2. Okay, and after it we will return our bits. So this is our code, and we have written our code after the explanation, identification, and problem statement. So let's try to run our code that it passes our test cases or not. So we have successfully passed our first test case and try to submit that we have calculate our all test cases or not. So let's see. So congratulations, we have the passed our all the test cases, and total test cases were the 202, 202 test cases we have total passed. And our function is it takes 58 milliseconds and beats 70.27% as users.